Okay, cool. So the last lecture of the night is going to be on control flow. So pretty much loops, functions, the stuff we've been using all day, but today we're going to get this lecture we're getting really granular with it. So we'll really understand them. So the challenge in general with programming is we want to write these programs that aren't just hard-coded, static, does the same thing every time. We want to have some sort of dynamic use, and we want to keep our code dry by using the same code multiple times instead of having to rewrite it every time. The early approach to this was the goto statements. If anyone programmed way back in the day, go-tos were the first oh, we'll go to this line, go to that line. This is an example of it. So here it'd be if the counter is greater than 15, we're going to go to line 15, then you'd have to come down, console log complete. But it's not yet. So if it's divisible by 3 and 5, go to 8. And you're just going to, it's go to and then the line number, which seems simple if you're doing maybe one or two things. But this is a pretty small function, and it's just madness already. It's spaghetti code. How having to trace where things are going is a nightmare. And it's not go to 3, you don't automatically know. But if you had a function that was I don't know, console log 3 or something, I don't know, it just it's not easy to follow. I don't even know where I would start with this one. So then there was this thing that was started called structured programming. It was made to get rid of the go-tos and have these blocks of code that are reusable. Blocks of code meaning things that start and end with curly brackets. And we can reuse this code in here, 15 times for this for loop. So it's nice. It makes code a lot drier and easier to understand. When you read a for loop, you know sort of what's going to happen. When you see an if statement, you sort of can read it closer to English. There's this quote, structured programming is a programming paradigm aimed to improve the clarity, quality, and development time of a computer program by making extensive use of subroutines, block structures, for and while loops, in contrast using simple tests and jumps such as the goto statement. This does the exact same thing. So much easier to read, right? So loops. We've used them today. We'll use them tomorrow. It's just a way to have a chunk of code and run it multiple times based on a condition. So we have this condition, and if the condition's true, we run the block of code. If it's false, we don't. It's just that straightforward of true, yes, do it, false, don't do it. And there's many different kinds. The while loop, we've been using this one. This one has the while condition and then does this until the condition is false. This one, I remember I was a little bit nervous of it when I was first learning it because I was really nervous of creating infinite loops. But it's not going to break your computer, I promise. Do it, see what happens. It's fun. But while loops are really useful, and in some ways, some algorithms and stuff are better for time and space complexity. So don't shy away from while loops. But anything you can do in a while loop, you can also do in a for loop. So the while is a reserved keyword, so we can't have a variable named while. Then the condition that we evaluate, and then it's the code is within curly brackets, and everything inside is indented, like we talked about today with clean code. So then the for loop. This is the while loop example, sorry. So this is just an example of we have the number, while it's less than or equal to 4, we're going to console log the number, and then it increase the number by 1. This is really key in while loops. If you're not remembering to change something in your condition, that's when you get the infinite loop. So while the number is 1, while it's less than or equal to 4, it is, so we console log the number, we increase it to 2, it's less than or equal to 4, so we console log the number, then we increase it to 3, it's true, console log 4, it's true, console log, and then it's 5. 5 is not greater than or less than or equal to 4, so it's false, so we end the while loop. Useful. Much more useful than, console log 1, console log 2, So that was a while loop. Again, anything you can do in a while loop, you can do in a for loop generally, and vice versa. I don't think there's a time when you wouldn't be able to do one or the other. So the for loop is used to iterate for a specific number of times based on the condition and whatnot you put in here. So we've all used a for loop today. So for, another reserved word. Can't name variables for. Initialize it, normally we say var I equals 0. You want to have the var in front of the I equals 0 because then if you don't, I becomes a global variable. And that's not great if you have like 2 for loops next to each other. Then it's like, what's going on? So yeah, just always have var I. But if you have a nested one, you might have var I and then inside that var j, very common. Then we have the condition. I is less than 5 or something like that, some condition. It doesn't necessarily have to be related to I though. You could have if something's like truthy or falsy in this, generally it's related to I because why else declare variable I equals 0. And then the change, the update. This is normally I++, adding 1 to I. But again, it can be anything. Yeah, you can get creative with your for loops. Then there's opening and closing brackets. These are all separated by semicolons. And then the code inside is all indented. One thing to note, you can actually do a for loop and then have these be like nothing, just like open parentheses, semicolon, semicolon, close parentheses. If you want to just do a thing, but don't do that. But you don't necessarily need a thing in each one of these things, but if you're not, you probably want to be using a different kind of loop. If you're not initializing anything or updating anything, maybe you want to be using a while loop because you just have a condition. So exact same thing. We're iterating through. We have the variable I whenever it's less than or equal to 5. Oh, this one's 5 instead of 4. And then we increase I by 1 and we console log the number. So just as before, it stops when it increases it to 6. So this is what's increasing it from 1 to 2, 2 to 3, 3 to 4. This is the condition it's checking. Yeah. Are there any questions on while and for loop, syntax? So what's great about loops is it keeps your code dry. Dry is a principle that you want in every programming anything. It means don't repeat yourself. So you don't want to, if you're writing the same line of code multiple times, there's probably a way, maybe a loop or a function that can do that work for you and you only have to write it once. The best programmers are lazy programmers. They only want to write as the bare minimum. So sort of channel that laziness in a good way. So if you wanted to log out the number 0 to 50 by 5, without loops, we would have to do this really boring, who wants to write that? That's not fun. No one's having fun writing console log in a number a bunch of times. But if we have a loop, we can make it 3 lines long. So we have the variable I. When it's less than or equal to 50, we're going to add 5 after every for loop. So we console log I, then we add 5 to log I, add 5. Same with the while. This is a few more lines of code, but you know, for loop, while loop, pretty much the exact same thing. We have I, this is the condition, this is it iterating. So you can see this, and this are all the same pieces of code, just in different orders. Yeah. So let's say we wanted to make a function called spell my word. This is real small, huh? Is that good? Cool. And it takes a word. And then if we want to just have a for loop that loops through this word and console logs each letter, we have the initialization of the counter. So we have I is 0, and then when I is less than word dot length, so we want to iterate through till we get to the end of the word, and then we'll increase I by 1 each time. And then we'll console log word at I. And we saw this in the last lecture about types. You can access a letter or character in a string with the brackets. So then if I called spell my word with, I don't know, chocolate, I think that's how you spell chocolate, it'll loop through and console log each one of these. So it's super useful if we want to go through and do something to each letter. I don't know what it would be, but like maybe we want to have a robot that's saying each letter. I don't know. So this is a great way we could have it loop through those things. So yeah, so the 3 sections, we initialize it, we set our condition, and then we update it. Another note, the I in the for loop or whatever letter, but generally an I, doesn't necessarily need to be for like getting an index, although it's useful, and that's why I think I is the go-to letter. We can use that to do some calculation. So if we wanted to make a function that's like sum these nums, and we pass in a number, and we have the sum, we just initialize it to 0, and we want to loop through from 0 to the end of that number and add to the sum to figure out what it is. We can do that by doing var I is 0, actually 1, because 0 to 0 is 0. I is less than num, less than or equal to, because we want to add num to it, and then I plus plus. Then we can do sum plus equals I, and then return sum. So then if we called sum these nums with 20, we should sum up all the numbers between 0 and 20. And we get 210. And I don't know off the top of my head if that's right or not, but like I'm going to assume so because the program said it is. That's why we write them, right? So yeah, I can be used to calculate things for more than just accessing it, but the most common uses is accessing like a character or an index in an array or something. Break, continue, return, all very important keywords. And you'll get more comfortable with them the more practice problems you do. Break will just like exit out of that loop. Continue will skip that current loop through that iteration and go to the next one. So it's not going to stop the loop. It's just going to be like, nope, not this iteration. And important note, especially when doing loops, is return exits the loop and exits the function. So if you have a return in a function and you hit it, you won't continue through that loop. So keep that in mind. If you want to be, there's very few cases you want to return inside of a for loop, because normally you want to continue doing all the things in the for loop and return after, unless you want to like exit early. So if we have a function, this isn't a great name, but loop through num, and we have var sum again. And let's say we want to only sum the odd numbers from 0 to the number for some reason. So let's rename this like sum odd nums. And if we did a for var I is 0, I is less than or equal to the num I plus plus, and we if I is even, we saw some of this coercion, falsy, truthy stuff before, so we're going to bang the modulus of I divided by 2. Because if it's even, it'll return 0, so we want it to be true if it's returning 0. So we're going to bang it. We'll console log even with I, else we'll console log odd with I, and we also want to sum plus equals I, because we're going to add all the odd numbers to sum, and at the end we want to return sum. So if we call sum odd nums with 5, it should be 5 plus 3 plus 1, so 9, right? Cool. But if we're like, we don't really need to console, or yeah, so if we want to like see how break, continue, whatever, if we do break, that's going to exit out of the for loop. So we'll never get these sums. So having a break in here might be good if we, let's say, hit like a maximum, I don't know, we've used all the CPUs, we're checking CPU usage or something. We want to break out of the for loop if we hit that. But we can do continue, and it's not going to affect, because maybe there's like more code down here. And we don't want to hit that if it's, or if we brought sum out here. You know, we have more conditions than just this if it's odd, if it's even. Let's say we want to do like if it's divisible by 3 or whatever. Sometimes we want to continue, sometimes we want to break, sometimes, but default add it to sum if we haven't like broken out of that for loop. And then if we return, like if we just return out of this, it's going to be similar to break. If we had a console log still in function, we're not going to hit it. But if this turned into a break, we would hit it. Does that make sense? So break only breaks out of the loop. Return ends the function. And continue just stops that iteration. Like if we put continue up here, we won't get any of the even logs. Yeah?
What does the bang do? I'm confused.
Oh, so this is the same as saying if it equals 0. So this is seeing like if I modulus 2, so I divided by 2, the remainder of that, whether or not it equals 0. So if it's even, it will return 0, which is falsy.
Right.
So if we do bang I modulus 2, that's the same thing as saying like, is this equal to 0?
Okay.
Yeah, it's just like another way to do it.
Thank you.
Yeah. Yeah.
So if you just left the if statement blank and didn't add, or didn't have the continue or the console log in there, would it still do the same thing?
Oh, yeah. So if we just like commented both these lines out, it's, yeah, exactly. It's pretty much doing the same thing. This isn't a super useful case of the continue break stuff. It's just like a small one. Yeah. I don't come across continue and break very often in my day-to-day work. But it's good to know like what exactly it's doing, because sometimes you'll see it and you'll be like, wait a second, which one continues iteration, which one ends the loop? So it's good to remember those things.
But wouldn't it just like continue by default? Like when would you add continue?
So continue, stop, it won't run this. It'll just start, it'll, continue will add one to I and start the for loop again for the next iteration. Yeah. That is a great question. Let's put a nested for loop in here and see what happens. J is less than, let's just say 4. And this should be J. So if we had, if, let's bring this, let's do if J equals 1, we'll break. And we'll console log. We are breaking. And then no matter what, we want to console log, have we broken? So if we see a have we broken after we are breaking, it only breaks out of the inner one. Yes. So have we broken comes after we are breaking. Yeah, the one that it's within. Great question. I think you would need to do a return, and that would break out of the function. I don't know off the top of my head if you can do like break from here and from the outer, but I'll look it up. Yeah.
We've done console logs with both commas and plus signs between strings and values. Is there a best practice or a reason why you would use either? And why does it give you a default space when you use it?
Great questions. Off the top of my head, I don't know if there's like one that's better than the other. I think it's more about personal preference. The best is to stay consistent. If you use commas, use commas. If you use pluses, use pluses. I like commas because it's just cleaner for me to read. And yeah, when you do console log and you separate values by commas, it adds a space between them for you.
Even if you don't do a space yourself?
Yeah, you could do console log hello, that's not how you spell, and world, and it'll be hello space world. Yeah. Okay, cool. So logical operators, ands and ors. We've used them, I'm sure you used them in some of the practice problems you did in the last workshop. The and is the double, I think it's called ampersand, the and the or is the two pipe characters. Yeah, and so they have different behaviors for sure. Sometimes, if something's not acting quite how you expect it, and you have like an and or symbols in there, check and make sure you're using the right one, because that's one of those like off by one kind of mistakes that are very common. And what it does is it compares two booleans. And like we talked about before with truthy and falsy, it'll coerce things into truthy and falsy for you, just like an if statement. So if we had like if we have var val1 is true, and var val2 is true, and we console log val1 and val2, and we console log val1 or val2. For true, it should be true, and true should be true, and true or true should be true. So in this case, it's going to behave both ways. Let me bring that to the top. So we get true and true. But if we turn val1 into false, then it's false and true. With the ands, it's false and true. Both have to be true in order to be true. So if we have false and true or false and false, it's going to be false. With the or, only one has to be true. So if we have false and true, as long as one is true, it's true. So that like and is like this and this, or is like this or. It sort of makes sense, but sometimes it's like in your head you have to map out. You can also have multiples. It doesn't have to be comparing two things. You can compare as many as you want. You can do or true. It'll also compare it. Same here, but just like with the two ands, they all have to be true in order for it to be true. Or's only one has to be true. And there's different diagrams out there of like if one is true, one is false, both are false, that kind of stuff that you can find. Not is also a logical operator, but we've gone over that one. Okay, functions. Yeah. So functions is a reusable chunk of code. We've used them tonight or all day today. They're super useful. So the anatomy of a function, we have the parameter, we have the function keyword, we have the function name, and we have the code block. So you know the general basic syntax of it. So using a function, so when you define a function, that doesn't mean that you ran the code. And that's something really important to keep in mind. You have to invoke it in order to do that code. Invoking it is when you use the parentheses and pass in an argument as for the parameter, or if it doesn't have any parameters, you know, you just have the empty parenthesis signs. Yeah. So these are two different ways to write a function. Both are completely valid. They won't throw any errors if you write a function this way or that way.
How do you write them day to day?
I do this one just because we'll go over like the main differences, but that one works in like almost any case where this one won't. There's some times where this, you might have some issues with hoisting and stuff. We'll talk about hoisting tomorrow in depth, but this one is just the safest in my opinion. But yeah, so there's like two different, this is a function declaration, this is a function expression. This part is the function expression. The var 2 plus equals is just declaring a variable. It's the function and beyond, that's the expression. So with the declaration, it's defining a function without requiring a variable assignment, so that's the var 2 plus equals. So the nice thing about this is that it gets hoisted, as it said, where you can invoke the function before or after it's declared, and it'll be usable. You won't get that like is undefined and you're like, I defined it right here, the way you might with the function expression. The function expression doesn't have the name here. That's like the big, you see like function 2 plus that. This, it's function and then the parameters right away. The nice thing about this is I do use the expression sometimes when I want to make an anonymous function, as they call it. Maybe I don't want to give a function a name because it's just like a quick one-line function. And it's just like within, I'm calling a bunch of array methods, and one of them I have an anonymous function in there. That's like the best case for it. Yeah, because this doesn't need to be named. The function declaration needs to be named. Does that make sense? You can play with them too. What I like to do sometimes is I've solved a problem, it's working, then switch it up. Like make one of the function declarations a function expression. Does it change the outcome? Maybe it does, maybe it doesn't. It's fun to try out. Okay, so parameters. Parameters are a placeholder in the function. It's what makes it so dynamic is you have this variable tax. Tax can change. But you'll do the same thing with that tax variable every time. They're not declared when you make the function. So you don't know what it's going to be when you're making the function. You have like an idea of an example or whatever, but anything can be passed in there, especially with JavaScript. Like any type can be passed in there. One good thing, and that you saw this with the clean code thing, especially with the magic thing, is if you have just like one letter names in here, you might know when you're writing it, oh yeah, Q stands for quote. But really being good about what you name your parameters with can be helpful when you're going back and like using the function. And then an argument. An argument is sort of like the yin to the yang of what a parameter is, or I guess, yeah. So when you invoke it, that's what an argument is. So the 8.9, that's an argument. Tax, the variable, is a parameter. So arguments are the values. Parameters are sort of like an idea of what the value will be. One thing to note is you have to have the arguments in the same order as the parameters, because you're going to be doing like the first argument you'll be using as tax, but if you accidentally put the price in the first argument, like you're going to think that the tax is 5.00 when it's not. So making sure the order is the same every time will save you a lot of headache. Okay, so take a second, look at this, figure out what sum will be. You know, if you console logged sum, what would that be? You're right. Yeah, it's going to be undefined because exactly, yeah. So it doesn't do anything. Well, it adds two numbers, but it doesn't do anything with them. It like adds them and it's like cool. But we don't want to make a function that doesn't do anything. So if we add the return, then this sum will be whatever the return value is of this. So yeah, now it does something. Now it's returning num1 plus num2. So sum will be 4. Return. Return is great. Sometimes it bites you when you're using it wrong, like in a for loop. Return is a keyword unique to a function's code body, so you can't have like a return just willy-nilly in your code, not inside of a function, because it's going to be like, I don't know what you want me to do here. So it stops execution of the function, and anything after the return keyword will not be executed, meaning like this console log. So if we had this function add numbers, this console log would never be hit, because if you do anything after a return, it doesn't run that code. And the return keyword passes whatever this value is to what it's being assigned to. Or if you're logging it, that's what it's logging, the return value. If you don't have a return value in your function, if you don't say like return num1 plus num2, the default return in a function is undefined. So you might have been seeing today in some of your practice problems, you have a function, you run it, and in green it has like undefined. It's like returning undefined. You're like, but I'm doing things. It's because you're not returning anything. Sometimes you don't want to return anything. That's totally fine. You don't need to. But if you're expecting to return something, you need the return thing, because otherwise it'll return undefined. And then there's examples on this REPL that you can check out. Any questions on return or conditional flow? Try to keep it short. I know it's a long day. Okay, cool. Going to